Finishing up the video from last time with example 3, we knew that we had to find the first term that would have error, that would actually have a value, I should say, that's less than 0.0005. That would coordinate with having an error less than 0.005 with an appropriate sum. And we began looking for the first time that you would find a term that would be that small. Now, if you saw 1.984 times 10 to the negative fourth, as you see right here, that's actually going to do the trick, because what you're going to see is that means you'll have 3 zeros, 0.000, and then a 1984. And that would be the first time that you're going to be smaller than 0.0005. So b sub 7, the seventh term, is going to really give us what we're looking for. Now, what we saw right here at the top of the screen is that the error was always going to be found by going to the next term. That if you wanted to find the error in the nth partial sum, you'd look to the n plus 1 term. So if I know that my seventh term is going to give me a value that's smaller than 0.005, 0005, I should say, that means that if I go right before that, going up to the sixth term, that will get me a sum that would have an error bound that's actually going to be smaller than 0.000198, meaning I'm guaranteed I'm accurate to 3 decimal places. I don't have to worry about rounding terms and affecting that third decimal place. So the last thing we need to do is very simply write out the sum going up to the sixth term. Remember, b sub 7 was what we were looking for. We're going to add right before that. And then the only thing you have to do very quickly is get this typed in to the calculator. So under math, if you go all the way down to really number 10, it's listed as number 0, you'll get a sigma. And rather than make n show up, I'll just have x show up. This would be x equals 0. We'll go to the top up here to get a 6. And then I'm going to make a fraction appear. We'll go alpha y equals. And I'll type in parentheses, -1. Bump that up to the n power. Well, that's our x power right now. Down below we'll have x factorial. So that's x math. A left arrow to probability. Bring down that factorial. Hit enter. You actually get a fraction. Now, we'd like to go to 3 decimal places. Under the math menu here, number 2 says please convert that to a decimal. And we'll get 0.368. So going to 3 decimal places, we can rest assured that this is what our sum is getting close to. We are accurate out to that third decimal place. We might not know what the true sum is, but that's a wonderful tool to have. Given that you're not going to know any true sums here outside of a telescoping or a geometric series, the best we can do is really just get as close to the true sum as we'd be asked to do. And this is a great way to accomplish that.